Algebra 1, Section 4-6, we're dealing with slope-intercept form. In slope-intercept form, hopefully you've seen it before, it's y equals mx plus b. M being the slope and b being the y-intercept. Now, in the slope-intercept form, the slope and the y-intercept always stay the same. What changes is different points, right? Because as I'm moving, my slope, my x and y change differently. So in order for me to have a proper equation, the only thing I need is a slope and y-intercept. Sometimes we'll be using the y and x to help us find the slope and the y-intercept. But in order for us to have a slope-intercept equation, we have to have slope and y-intercept. So for example, when they want us to write the equation on 1a, slope is 1/4, so y stays y, equals, this is our m, and this is our b. So 1/4 x plus 4. So remember, you fill in the m and the b, but the y and the x stay the same, because we need that to find out how to actually apply the equation. The second one here just gives us 2 points, okay? When they give us 2 points, we need to first find the equation, the slope, our m. And remember the equation for slope? M equals y2 minus y1 over x2 minus x1. So this is our x1, y1. This is our x2, y2. So, all right. Y2 is 1, and our y1 is 2, over our x2 is -4, and our y2 is -2, but it's minus a -2. So 1 minus 2 is -1, and -4 minus a -2, this is plus, right? Minus a negative is the same thing as saying plus, so -4 plus 2 gives us -2. These negatives cancel out, and I have positive 1/2. That is my m, but I also need my b. So this is the case where I'm going to use one of the points. Now, because both of these points are on the line I'm about to create, it doesn't matter which one I choose. So let's choose these ones because it's a smaller number. And I'm going to plug in, because at some time in the line, this is the x and the y, right? Because I cannot solve an equation with more than one variable. And if I just plug in my slope, I can't get my b because there's an x and y missing. So I'm going to use one of my for instance, and either of these points are for instance. Both of these points fall on the line we're about to create. So one time or another, this is the x and the y for this equation. So I'm going to plug in this for my y, which is 2, and this for my x, which is -2, and they're being multiplied. So I'm going to solve. See, now I only have a b left. And again, I'm only plugging these in not because I need it for the equation, but when I plug these in, the only variable I have left is b. Now I can solve. And once I solve, then I'm going to use my m and my b to create my equation. So -2 times 2 is -1 plus b. And I'm going to bring down 2. Then I'm going to solve b by isolating it by adding 1 to both sides. I end up with 3 equals b. So now I have m right here, and I have b right here. So now I can, just like this one, I can plug it in. Y equals my m, which is 1/2 x plus 3. And again, see how that yx stays the same? They stay x and y. I only plugged it in here to find b. Once I find it, I can ignore it again, and I can set aside y equals 1/2 x plus 3. What this means is, if I plug this in, it'll state it true. If I plug this in, it'll state this true. Okay? So, hopefully that makes sense. Number 2 is just to write in a slope-intercept form and then graph. So, in order for me to put this in slope-intercept form, I have to solve for y. See how y by itself? So I'm going to start by subtracting 3x, because 3x. And again, I want it in y equals mx plus b form. So when I cancel this out and I bring down the 2y, I want to put the 3x in front. Now again, I can't combine them because this doesn't have an x. I can't combine them. So I'm going to do negative 3x, and this is a positive 6. And again, I do that because I want to make it into y equals mx plus b form. Now, I know the y, right, is there, but there's a 2 in front of it for this one, even though it's the only one on that side. So in order for me to do it, I have to divide by 2. And here's a common mistake that a lot of people make. I have to divide this whole thing by 2. So I'm not just dividing 6 by 2. See, when I add and subtract from both sides of an equation, I can do it to the like terms. But when I'm dividing or multiplying, I have to do it to all the terms on that side. So if I'm dividing by 2 to cancel this, I have to divide by the whole term. So what that means is, I'll have a y on this side, right? But then I have to share 2 to each term. So it's going to equal negative 3x over 2 plus 6 over 2. See how that works? Okay, one more time, I have to take this and I have to put it under both sides. And that's only if I'm dividing, right? I'm dividing by the whole thing. Okay, I'm dividing both sides. So, negative 3 over 2, we're going to leave as negative 3 over 2. Because I'm solving using this, I don't want to, because I'm solving using this, I don't want a decimal. I want to leave it in the fraction, even though it's an improper fraction. And then 6 divided by 2 is positive 3. So, here's the trick. We can do a chart, of course, to graph this. But what we can also do is pay attention to the y-intercept and the slope. Okay? The y-intercept tells me where it crosses the y-axis. Do you remember that? So that means at 3 on the y, that's where it is. With this equation, I can use the y-intercept, the b, as a starting point. So I'm going to start here. And this is going to tell me where to go. Again, the top tells me rise and the bottom tells me run. So the top tells me where to move up and down. Because the top is a negative 3, that means I'm going to move down 3. 1, 2, 3. But the bottom is a positive 2. So I'm not going to move backwards, I'm going to move forwards 2. Which makes sense because when I should do it 2 times. 1, 2, 3, 1, 2. When I connect them, because the slope is a negative, the line is a negative slope, so therefore it doesn't match. So make sure to check that. So one more time, this positive 3 tells me where to start on the y-axis, this b. The y-intercept tells me where to start on the y-axis, where it intercepts the y. And then I can apply the slope. The top tells me how much to move up and down, and the bottom tells me how much to move left and right. So go ahead and write this down. Page 272, numbers 5 and 8, 272, numbers 5 and 8, and I will see you in class.